Let's go to the peak, peak. Let's go catch a time. No globe got you in a. Let's go to the peak, peak. Let's go catch a time. No globe got you in a bind. Clock stop, found a baseline. Feel angles like these aren't hard to come by. Flat map, we got that design. Refraction caught in a lie. Star clocks record the sky. Hands up, catch that peak line. Occlusion says what's real. Globe math can't seal the deal. Look up, watch the mountain climb. Star drop, measure right on time. Baseline distance, trig so clean. No curve in the sightline seen. Globies say refraction's high, but their numbers don't apply. Flat frame gives the truth in kind. Drop rates lock, stars don't lie. Star clocks record the sky. Hands up, catch that peak line. Occlusion says what's real. Globe math can't seal the deal. Look up, watch the mountain climb. Star drop measured right on time. Baseline distance trig so clean. No curve in the sightline seen. Globies say refraction's high, but their numbers don't apply. Flat frame gives the truth in kind. Drop rates lock, stars don't lie. Star clocks record the sky. Hands up, catch that peak line. Baseline, timing's true. Geometry breaks globe view. Mountains blocking stars like math. Angles trace the occlusion path. Tick-tock, stopwatch, don't delay. Catch the moment night meets day. Globe heads twist, it's just a bend, but the angles won't pretend. Every distance, height, and climb. Flat earth locks the perfect time. Final clocks, no globe to find. Hands up, truth is realigned. Occlusion proves the scheme. Flat earth wins the timing dream. That peak line, baseline, timing's true. Geometry breaks globe view. Mountains blocking stars like math. Angles trace the occlusion path. Tick-tock, stopwatch, don't delay. Catch the moment night meets day. Let's go to the peak, peak. Let's go catch a time. No globe, gotcha in a bind. Clock stop, found a baseline. Catch the moment night meets day.
Welcome, lads and ladettes, to Aether Roundtable number 101, a brief history of Voigt transformations.
Thank you for that introduction. Today, Man of Stone is going to be taking us on a brief history of Voigt transformations / the Lorentz transformation. So there's a history between, did Einstein steal from Poincare? Did he steal from Lorentz? Did he steal from Voigt? Well, we're going to go over the history of the original transformation, take a look at its components, and then we're going to lay that foundation for a future presentation going over the full history of it and comparing and contrasting. But here we're going to look at the original derivation and the purpose for which it was derived. Stone, whenever you're ready, good sir.
Yeah, call it a giant setup. Shane, in the PDF, you want to be on page 45. And I'm hearing myself twice.
Oh,
Actually, let me kill the... There, now I only hear myself once.
no, you were sharing, you were like mirroring Discord instead of PDF.
Desktop. Can see it now. Okay, so I'll go over to page 5 or 4.5 actually. Get that right?
Yep.
We're starting chapter 2. It's actually 44 in the book, but it's the PDF page 45. Right about there. Looking good. Prioritizing space-time theories. Space campers, here we go. And quote. Yeah, actually, no. We'll do the quote second. Up top in the italics there. It is well known in the physics community that Albert Einstein was a career plagiarist. Immediately after the Annales de Physique, published in Einstein's 1905 paper on the theory of relativity, which wanted for a single reference to the published work of the Einsteins' predecessors, Walt Kaufmann dubbed the special theory of relativity the, quote, Lorentz-Einstein theory. Kaufmann was being overly generous to Einstein at the expense of Frenchman Henri Poincaré. Quote by Nordman here, all this was maintained by Poincaré and others long before the time of Einstein, and one does injustice to truth in ascribing the discovery to him. Oh, what an awesome setup. Here's the intro. It is easily proven that Albert Einstein did not originate the special theory of relativity in its entirety or even in its majority. The historic record is readily available. Ludwig Gustav Lange, Voldemar Voigt, Heaviside, Hertz, Fitzgerald, Larmor, Lorentz, Poincaré, Drude, Langevin, and many others slowly developed the theory step by step and based it on thousands of years of recorded thought and research. Einstein may have made a few contributions to the theory, such as the relativistic equations for aberration and the Doppler-Fizeau effect, though he has also rendered an incorrect equation for the transverse mass of an electron, which, when corrected, becomes Lorentz's equation. Albert Einstein's first work on the theory of relativity did not appear until 1905. There is substantial evidence that Einstein did not write this 1905 paper on the quote principle of relativity alone. His wife, Mileva Einstein-Merity, may have been co-author or the sole author of the work. So-called Lorentz transformation. The mathematical transformations in relativity theory are called Lorentz transformations, an appellation supplied by Émile Cohn and Henri Poincaré. The record indicates that Voigt, Heaviside, Fitzgerald, Lorentz, Larmor, Poincaré, Cohn, Langevin, and others began developing the mathematical expressions of the theory of relativity some 18 years before Einstein, and completed them before Einstein published on the subject. Voigt's space-time transformation. The transformation is not Lorentz's transformation, as is and was widely known. Quote, nor did Lorentz discover these equations. They were first used by Voigt. You find the Brockhaus Encyclopedia succinctly stating, Voigt presented, among the introduction of the term tensor, a theory of elasticity. In the treatment of optical properties, he formulated for the first time in 1887 the formulas which later became known through the special theory of relativity as the Lorentz transformation. Quote, here's a nice one in German we're not going to read. And in 1887, Voigt published the following relativistic transformation of space-time coordinates. And that's x prime equals v, or x minus vt, y prime is y over lambda, z is z over lambda, t prime is t minus vx over c squared, leaving lambda equaling 1 over the infamous root of 1 minus v squared over c squared. Here we have Minkowski. Maxwell's and Lorentz's theory are not really opposites, but rather the rigid and the non-rigid Zeppelin's and Parseval's electron. In the interest of history, I want yet to add that the transformations which play the main role in the principle of relativity were first mathematically formulated by Voigt in the year 1887. With the aid of these transformations, Voigt had already drawn conclusions at that time regarding the Doppler effect, and that's the German translation for that paragraph. To which Voigt responded, Mr. Minkowski, called work of mine. It addressed the application of the Doppler effect to some special cases which arise due to the elasticity or the elastic theory of light, not the electromagnetic. It had already at that time revealed some of the consequences which were later arrived at through the electromagnetic theory. Again, the German for that. 2.4 length contraction. In 1905, Mileva and Albert Einstein asserted without reference to prior authors, quote, a rigid body which, measured in a state of rest, has the form of a sphere, therefore has in a state of motion, viewed from the stationary system, the form of an ellipsoid of revolution with the axes, being r, the root of, again, 1 minus v over c squared, and then r and r. Thus, whereas y and z dimensions of the sphere, and therefore of every rigid body of no matter what form, do not appear modified by the motion, the x dimension appears shortened in the ratio of 1 to the root of 1 minus v squared over c squared. For example, the greater value of mu, v, the greater the shortening. And we'll just call it v equals c. All moving objects, viewed from the stationary system, shrivel up into plane figures. Footnote, that is, a body possessing a spherical form when examined at rest. For velocities greater than that of light, our deliberations become meaningless. We shall, however, find in what follows that the velocity of light in our theory plays the part, physically, of an infinitely great velocity. Poincaré in 04, quote, from all these results, if they are confirmed, would arise an entirely new mechanics which would be above all characterized by this fact that no velocity could surpass that of light, any more than a temperature could fall below the zero absolute, because bodies would oppose an increasing inertia to the causes which would tend to accelerate their motion. And this inertia would become infinite when one approached the velocity of light. And Boscovich argued in 1763 in the second supplement of his Natural Philosophy in section 21. Again, it is to be observed, first of all, that from this principle of the invariance of those things, of which we cannot perceive the change through our senses, there comes forth the method that we use for comparing the magnitudes of intervals with one another. Here, that which is taken as a measure is assumed to be invariant. Also, we make use of the axiom, things that are equal to the same thing are equal to one another, and from this is deduced another one pertaining to the same thing, namely, things that are equal multiples or submultiples of each are also equal to one another. And also this, things that coincide are equal. We take a wooden or iron 10-foot rod, and if we find that this is congruent with one given interval when applied to it either once or 100 times, and also congruent to another interval when applied to it either once or 100 times, then we say that these intervals are equal. Further, we consider the wooden or iron 10-foot rod to be the same standard of comparison after translation. Now, if it consisted of perfectly continuous and solid matter, we might hold it to be exactly the same standard of comparison. But in my theory of points at a distance from one another, all the points of the 10-foot rod, while they are being transferred, really change the distance continually. For the distance is constituted by those real modes of existence, and these are continually changing. But if they are changed in such a manner that the modes which follow establish real relations of equal distances, the standard of comparison will not be identically the same, and yet will still be an equal one. The equality of the measured intervals will be correctly determined. We can no more transfer the length of the 10-foot rod, constituted in its first position by the first real modes, to the place of the length constituted in its second position by the second real modes, than we are able to do so for intervals themselves, which we compare by measurement. But because we perceive none of this change during the translation, such as may demonstrate to us a relation of length, therefore we take that length to be the same. But really in this translation, it will always suffer some slight change. It might happen that it underwent even some very great change, common to it and our senses, so that we should not perceive the change, and that when restored to its former position, it would return to a state equal and similar to that which it had at first. However, there is always some slight change owing to the fact that the forces which connect the points of matter will be changed to some slight extent if its position is altered with respect to all the rest of the universe. Indeed, the same is the case in the ordinary theory. For no body is quite without little spaces interspersed within it, altogether incapable of being compressed or dilated. And this dilation and compression undoubtedly occurs in every case of translation, at least to a slight extent. We, however, consider the measure to be the same so long as we do not perceive any alteration, as I have already remarked. Wow, that was quite the section. Hey, gang? Did you follow?
Definitely. We're back to where we started.
That was a logical roller coaster. Okay, 22. The consequence of all this is that we are quite unable to obtain a direct knowledge of an absolute distances, and we cannot compare them with one another by a common standard. We have to estimate magnitudes by the ideas through which we recognize them, and to take them as common standards, those measures which ordinary people think suffer no change. But philosophers should recognize that there is a change, since they know of no cause in which the equality is destroyed. By a perceptible change, they consider that the change is made equally. Further, although the distance is really changed when, as in the case of the translation of the 10-foot rod, the position of the points of matter is altered, those real modes which constitute the distance being altered is really changed when. Yeah, the distance is really changed when those modes constitute the distance being altered. Nevertheless, if the change takes place in such a way that the second distance is exactly equal to the first, we shall call it the same and say that it is altered in no way, so that the equal distances between the same ends will be said to be the same distance and the magnitude will be said the same. Okay, great. And this is defined by means of these equal distances, just as also two parallel directions will also be included under the same name of the same direction. In what follows, we shall say that the distance is not changed, or the direction, unless the magnitude of the distance or the parallelism is altered. Oh, wow. Quite the quote there. Holy crap. That was long. Okay, over to Fitzgerald. I have read with much interest Messrs. Michelson and Morley's wonderfully delicate experiment attempting to decide the important question as to how far the ether is carried along by the Earth. Their results seems opposed to other experiments showing that the ether in the air can be carried along only to an inappreciable extent. I would suggest that almost the only hypothesis that can reconcile this opposition is that the length of material bodies changes according as they are moving through the ether or across it, by an amount depending on the square of the ratio of the velocity of that to light. We know.
It's like, hey, how much does it change by? Well, how much do you need?
Exactly. According to the ratio, of course.
Dude, it's like real quick. That V over C is that's called the Sagnac effect. That's what's measured with interferometry for realsies that they say shouldn't exist and whatnot. But like, how much do we need? That amount. That's how much it's contracted by.
Oh, it depends on the square of the ratio, don't you know? Okay, we know that electric forces are affected by the motion of the electrified bodies relative to each other. And it seems a not improbable supposition that the molecular forces are affected by the motion, and that the size of a body alters consequently. It would be very important if secular experiments on electrical attractions between permanently electrified bodies, such as in a very delicate quadrant electrometer, were instituted in some of the equatorial parts of the Earth to observe whether there is any diurnal and annual variation of attraction. Diurnal, due to the rotation of the Earth being added and subtracted from its orbital velocity, and annual similarity for its orbital velocity and the motion of the solar system. Yes, a relationship that I indeed find myself leaning towards whenever people start to talk about the computation of etheric speed over the surface of the Earth, in consideration of the heliosexual model assertion that we're doing 30 kilometers per second. It's like, okay.
They're also assuming the Earth is pulling the ether, right? Because obviously Earth's moving. That's what motion
Yeah.
is. Motion is. So that's the context.
Yeah.
My
So it's all
personal
about this.
favesy
What's
was
that?
when it bounces. So my personal favorites was when the ether gets trapped in the telescope and it bounces back in the opposite direction of the motion, and it's carrying the light backwards at 30 kilometers a second.
I like etheric vortices that just pop in and out of existence when things don't need them to, and that's why things fall out of space or whatever.
I like when their velocity analysis ends at whatever speed we're allegedly doing around the sun. And nothing to do with what the sun is doing around the galaxy, and nothing to do with what the galaxy is doing around the universe. If it's all one, then it's got to be the others too. And those never seem to show up in the analysis of velocity, to do with the anisotropic speed of light, etc., which we're about to cover here, I'm sure.
Only
know what I
when
mean?
they do only when they do the role play and consider
Right.
all the motion being relative to the CMB, which is illegal for them anyway. If all motion's relative to the CMB, where's our velocity component at on Earth, brother?
It's on Earth when we need it there for purposes.
All right, Hendrik Antoon Lorentz had averred the same in 1892 and stated in 1895, quote, "The displacement would naturally bring about this disposition of the molecules of its own accord and thus effect a shortening in the direction of motion in the proportion of 1 to, you guessed it, root over 1 minus v squared over c squared, in accordance with the formulae, plural, given in the above-mentioned paragraph." As in, like I was saying, dude. Okay, so anyways, 1904, Lorentz affirmed that, quote, in section 8, "Thus far, we have only used the fundamental equations without any new assumptions. I shall now suppose that the electrons, which I take to be spheres of a radius r in the state of rest, have their dimensions changed by the effect of a translation, the dimensions in the direction of the motion becoming kl times," whatever I guess that is, "and those in perpendicular directions L times smaller." KL times smaller and L times smaller. Longitudinal versus lateral motion. Okay. In this deformation, which may be represented by L over KL, L over L, L over L, each element of volume is understood to preserve its charge. Now that's just where things get all hay. People start mixing up mass and energy together, and it's all screwed. It's all
a dark turn.
Oh, it is so ill-conceived. I can't believe they picked up that ball and have run with it for so long. Nobody said a word.
They built a bomb on it.
Wow. Okay, dynamic length contraction 2.5. In Lorentz's synthetic physical theory, length contraction is a dynamic theorem following from Maxwell's and Heaviside's work on the dynamics of the ether. 6. Kinematic length contraction. In the Einstein's fallacy of Petitio Principi of 1905, a change in length is merely presupposed without any physical theory to justify it. Then the precise factor is arrived at through induction from the allegedly observed invariance of light speed, which is an allegedly known empirical fact, not an a priori postulate. No one disputes that Einstein knew Lorentz's contraction hypothesis. The Einstein simply used the idea without crediting Lorentz, then Einstein called it a natural consequence of, quote, the two postulates in 1907. Since the postulates are empirical observations, the natural consequences are arrived at through induction, not deduction. In other words, the hypothesis of length contraction is more fundamental than the law of light speed invariance.
Well said.
One must first propose a priori a change in length before one can derive the precise factor of it through induction from the supposed empirical fact of light speed invariance. And the so-called, quote, natural consequence is instead the inductively determined factor arrived at from the presupposed a priori and ad hoc hypothesis that length must change with velocity relative to the, quote, resting system. In the natural Ko-Fi paper, the resting system is Newton's absolute space in order for light speed to be invariant in moving systems, quote. In the Einstein 05 paper, moving systems are in motion relative to Newton's absolute space. This presupposed change in length is more ad hoc in the Einstein's 905 paper than it is in the Lorentz's synthetic theory, which attempts a dynamic exposition on it as physics must. It was Poincaré, not Einstein nor Minkowski, who first recognized the group of properties of the Lorentz transformation and reciprocal length contraction, and who introduced a quadridimensional exposition on the length contraction, which renders it, in terms of a mathematical quadridimensional spacetime, a matter of cognitive perspective. Later, many would attempt to mask Einstein's plagiarism by arguing the issue of perspective, which nowhere appeared in the Einstein's work of 1905, where length contraction is merely presupposed without justification, then inductively demonstrated with Poincaré's operationalist thought experiment of clocks synchronized by light signals on the suppositions that light speed is invariant and that length must change to render it so.
At least when they say it like that, it doesn't sound as retarded, but it's saying it's putting a little flavor text on it is all.
It's all like, dude, you can't do that. Dude, you can't do that. Anyways, 2.7 time dilation, one of my favorites. Okay, Boscovich in 1763, in his second supplement to his Natural Philosophy, in section 24, says, what has been said with regard to the measurement of space, without difficulty, can be applied to time. In this also we have no definite and constant measurement. We obtain all that is possible from motion, but we cannot get a motion that is perfectly uniform. We've remarked on many things that belong to this subject and bear upon the nature and succession of these ideas in our notes. I will but add here that in the measurement of time, not even ordinary people think that the same standard measure of time can be translated from one time to another time. They see that it is another, consider that it is an equal, on account of some assumed uniform motion. Just as with the measurement of time, so in my theory with the measurement of space, it is impossible to transfer a fixed length from its place to some other, just as it is impossible to transfer a fixed interval of time, so that it can be used for the purpose of comparing two of them by means of a third. In both cases, a second length or a second duration is substituted, which is supposed to be equal to the first. That is to say, fresh real positions of the points of the same 10-foot rod, which constitute a new distance, such as a new circuit may be made by, or a new circuit made by the same rod, or a fresh temporal distance between two beginnings and two ends. In my theory, there is in each case exactly the same analogy between space and time. Ordinary people think that it is only for measurement of space that the standard of measurement is the same. Almost all other philosophers, except myself, hold that it can at least be considered to be the same from the idea that the measure is perfectly solid and continuous, but that in time there is only equality. But I, for my part, only admit in either case the equality and never the identity. I have no idea what he's talking about.
Dude, I was about to say, Yo, Stone, what
Neither do I.
What did that guy just say?
I would have to. I'd have to sit and stare at that for a couple of minutes to work it out, and I really don't think it's worth my time.
No worries.
There could be some nugget in there, but I doubt it. Just talking about people's perception of how we measure one, how we measure the other, and there is some contrast there that people aren't considering, but he doesn't.
So mission successful. If that's what you're going for, you nailed it.
Yeah, Larmor agreed with Boscovich and set the scale for time dilation, thereby completing the misnamed Lorentz transformation, which Lorentz, Poincaré, and the Einsteins later adopted. 2.8 Final form of the transformation. The components of the Lorentz transformation evolved as follows. From the Aristotelian, Bradwardian, Galilean transformation, we have x prime equals x minus vt, y prime is y, z prime is zt, t prime is t. Voigt, 1887, introduced the relativity of simultaneity, t prime equals t minus vx over c squared. Fitzgerald, in 1889, introduced the scale factor of length contraction, Fitzgerald did in 89, giving the mathematical voice to Boscovich's concept. X prime equals
Whatever
x
we
minus
just
vt.
read from Boscovich is that.
We did. That's right there. X prime equals x minus vt over, you guessed it, root of 1 minus v squared over c squared. Whee! Larmor, but 6 years up to 1900, introduced the scale factor of time dilatation. No, it's just dilation. That's a typo, guys. In order to quantify the Boscovichian concept of time dilatation, and published the Lorentz transformation in 1897. You can read it there. I'm not going to go through it again. You guessed it. Root of 1 minus v squared over c squared, playing the, the dominant denominator role here with both, x movement, transformation, forward, we see that longitudinal movement, and time. We are to treat them with the same kind of ratio setup, movement and time. Okay, Lorentz himself acknowledged Voigt's priority and was uncomfortable with Poincaré's term Lorentz transformation. Lorentz wrote to Voigt, "Of course, I will not miss the first opportunity to mention that the concerned transformation and the introduction of a local time has been your idea." Sure, buddy, trust me. Lorentz kept his word, though, in a paper, Über das Doppler Prinzip, published in 1887, by God, and which, to my regret, has escaped my notice all these years. Voigt has applied to the equations in the form of 6, section 3 of this book, a transformation equivalent to the formulae to a 7288. The idea of the transformations used above and in section 44 might, therefore, have been borrowed from Voigt, and the proof that it does not alter the form of the equations for the free ether is contained in this paper, as in the proof is here. And, quote, "It was these considerations published by me in 04, which gave rise to the dissertation by Poincaré on the dynamics of the electron, in which he has attached my name to the transformation of which I have just spoken. I am obliged to again note the observation that the same transformation itself was previously hit upon in an article from Mr. Voigt published in 87, and I did not remove the artifice from it to the fullest extent possible. In fact, for certain of the physical magnitudes which enter in the formulae, I have not indicated transformation which suits best. This has been done by Poincaré and later by Einstein and Minkowski. To discover the transformations of relativity, as I will call them now, yada yada, there's your French. And here we go again. Though Lorentz denied knowledge of Voigt transformation, it is quite likely Lorentz did know of it. Lorentz was keenly interested in theories which would explain Michelson's negative result, although it was not a negative result, as did Voigt's theory, which was published in the highly respected and widely read Nachrichten von der Königlichen, that's it, Gesellschaft der Wissenschaften und der August Universität zu Göttingen. Given that Voigt's transformation differs from the Lorentz transformation of modern relativity theories, some have wondered why Lorentz credited Voigt with the transformation. Schroeder published a collection of letters between Weikert, Lorentz, quote, Hendrik Lorentz und Emil Weikert, archive, page. Okay. In addition to the fact that Lorentz again denied his friend Poincaré's legacy, Lorentz's letters are noteworthy for their elucidation of his thought process and the development of his imperfect versions of the transformation, which ill-advisedly bears his name. Schroeder's article should be read by all interested in the history of the Lorentz transformation. In 1900, Larmor published the following chapter in his most famous work, the award-winning essay Aether and Matter, which was, quote, completed at the end of the year 1898, and had Larmor already published the Lorentz transformation in near-modern form in 1897. Loganov has stressed the fact that Poincaré selflessly attributed to Lorentz that which Poincaré had accomplished. Lorentz, alternately and depending on the audience, credited Poincaré and Einstein for the same innovations. Poincaré's priority is established by the dates of publication. Loganov has also stressed that many have failed to understand the significance of Poincaré's statements, wrongfully attributing priority to Einstein, which rightfully belongs to Poincaré. Loganov states here inter alia. Poincaré writes, the idea of Lorentz. But Lorentz never wrote such words before Poincaré. We see that invariance of the equations of the electromagnetic field under the transformations of Lorentz group results in the relativity principle being fulfilled in electromagnetic phenomena. In other words, the relativity principle for electromagnetic phenomena follows from the Maxwell-Lorentz equations in the form of a rigorous mathematical truth. Ooh.
They're talking about conceptual dynamic processes here.
Yeah,
That no one's ever. Their math. Oh my god.
But the-
They're using such reverence.
we've got some special numbers, and they work out. It must be underlined that by having established the group nature of the set of all purely spatial transformations together with the Lorentz transformations that leave the equations of the electrodynamics invariant, Poincaré thus discovered the existence in physics of an essentially new type of symmetry related to the group of linear space-time transformations, which he called the Lorentz group. Poincaré thus introduces the physical concept of gravitational waves, exchange of which generates gravitational forces and supplies an estimation of the contribution of relativistic corrections to Newton's law of gravity. For example, he shows... Oh, no, this is awesome, hey?
Yeah, I'll let Stone go ahead and finish that out, and then I'll
Oh,
explain
yeah, yeah, okay. For example, he shows that the terms of first order in V over C cancel out exactly, and so the relativistic corrections to Newton's law are quantities of the order of V over C squared, V over C all squared. It is here that such concepts as the following first appeared. The Lorentz group, invariance of the equations of the electromagnetic field with respect to the Lorentz transformations, the transformation laws for charge and current, the additional formulae, or the addition formulae of velocities, the transformation laws of force. Here also Poincaré extends the transformation laws to all the forces of nature, whatever their origin might be.
So vague.
Good qualifier to toss that in there. In 1905, without reference to prior... What's up?
Which generates gravitational forces and supplies the estimation of the contribution of relativistic correction. So, like, hey, we needed some. We don't know how much, but we got that exact amount from this, and we're gonna keep it super big. Like, this is the goofiest sentence I've ever read in a scientific paper before, and
It's all about light, bro.
I think we've probably heard Whitsitt talk about how Poincaré, invented the theory, but then like didn't go through with publishing it because he felt bad about imposing their mathematical framework on nature, because he realized that was like, not a real representation of anything physically meaningful. So he backed out of it for philosophical reasons, and then they just used Einstein to push it forward. Same framework and everything. So we're looking at like the root philosophy of what the mathematics means, because it's more than, like they didn't just come up with these numbers for no reasons. They represent a way to express a philosophical outlook on the motion of Earth and the cosmos and our place in it.
And how we have to correct things in nature.
Yes, dude.
Right, because things naturally occurring can't have that happen.
In 1905, without
Dude,
reference to prior...
the balls on these guys, dude. Sorry, the balls on these guys, dude. They're like, nature's messed up. We're gonna go ahead and look gamma factor it.
That's like, oh, God fucked up. Let me fix it for you real quick. Like, he doesn't know. Like, a while. Like, it's all right. Let's let it roll.
We're good. We got it sussed. Everybody is saved. In 1905, without reference to prior authors, Mileva and Albert Einstein wrote, quote, "It follows from this relation, and the one previously found that your angle over V here equals 1, So that the transformation equations which have been found become this famous set of variables, and finally where beta equals, you guessed it, 1 over the root of 1 minus v squared over c squared. Given the facts that Galileo popularized the concept of the principle of relativity, Lange took it from absolute space and absolute time. Voigt introduced the relativity transformation, and Poincaré first demonstrated relative simultaneity. Why is the concept popularly referred to as Einstein's special theory of relativity? Einstein contributed next to nothing to the special principle of relativity. Why are the popular misconceptions of Einstein and his supposed discoveries, which misconceptions are fed by the scientific community and the media and the factual historic record itself, at odds? Is exposing the truth counterproductive if it means the downfall of a hero and the death of a religion?
Yes. Absolutely
Yes.
Absolutely.
I thought about it. I thought about it for a few milliseconds, and there you go. Yep.
I didn't even think. Nope.
Dude, you can see we have different answers to this specific question drastically, and that's what causes the difference between us, I think, between people writing this paper and us.
Contrary to
Exactly.
the view of some Einstein advocates that Einstein worked in near complete isolation from both scientific literature and the physics community, many have pointed out that Einstein had easy access to the literature at the Swiss Patent Office and was heavily immersed in the most recent physics literature of the day as a prolific reviewer of that literature for the Beiblätter zu den Annalen der Physik. Jules Leveugle has stressed the fact that Einstein and Planck were exposed to the recent writings of Poincaré and Lorentz through many sources, including Beiblätter, etc. Einstein published 21 reviews of the Beiblätter in 1905. Leveugle points out in his book, Poincaré des questions sur la science, that the Beiblätter published the following review of Lorentz's 1904 paper by Richard Ganz in this 1905 publication in February here. And there's the German for it. And I think that's about where we're going to end. Are we not? Or maybe there's a little more here. Ganz also published a paper here. No,
Yeah,
not
you're-
quite. We're
you're
into
good if
page
you wanna tap here.
54. Page 54, after the indent, Ganz also published a paper, Zur Elektrodynamik in bewegten Körpern, Annalen der Physik, Series 4, volume 1905. Kohn published a paper that cited Lorentz's 1904 paper containing the transformation, with which Kohn paper Einstein was familiar. Zur Elektrodynamik wirkt System, yada, 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 from Berlin in 1904 in November at 1295. Okay, Einstein cited Kohn's paper in his Yarbrough review of 1907, and a copy of Kohn's 04 paper is in his preserved collection. Busted.
Cited in the rough draft, dude.
It's like, dude, he's got a copy. Pretty sure he was referring to it. And that is what the rest of this paragraph and 2 paragraphs continue to reinforce, is all of the papers and reviews that Einstein had in hand and access to review all the time. And that, I guess that kind of takes us to the end of where we want to be this
Dude,
time around.
Absolutely. And more recently, his private letters to his wife Malavia were leaked or discovered or whatever, and he talks about in I think the year was 1888 or something like that. It was before he published his paper, but he was like, "Yo, I got to check out what Lorentz is up to," and this guy named Paul Drude on his book of optics. So he knew all about these guys. He knew all about their transformations and ratios for explaining Michelson-Morley, or trying to explain Michelson-Morley. So like when he comes out of his paper and he's just like, this is a natural consequence of the empirically direct. This is how he knew about all this stuff. He was in it, and just didn't cite a single person. Couldn't be bothered.
That's a funny thing. So, I just, this was the best section for you to read. I had so many French and German names that none of us had any hope.
Yes.
And you nailed every
Yes.
one of them, and I'm super proud.
Thank you.
You did such a great job. Thank you,
Many,
sir.
many thanks. It is my absolute pleasure to provide. Yes. So glad I
Such a good
could
read.
be the guy. Cool. That was kind of fun. Good workout.
I fucking bet it just kept going for a while.
It did. This guy had plenty of citation. Holy crap.
Like if you didn't have any other background and you were in school and your income and future depended on you understanding this, like you might get behind the bullshit that we just read in a scientific capacity. You might be like, I don't get all of that, right? But you know, I'm in. Let's go. You know, I can see people.
Well, they're smart.
There's no evidence that links don't not contract. Like, okay.
They're smart.
They don't
That's funny.
Right.
Like you would never know.
They
It's
must-
not a made up thing that in a thought experiment for a dude. Like none of this actually has any mechanism. We're just gonna describe it mathematically over and over again until people believe it's real. It's like, oh, that's how you.
Shane, I think you
Yeah,
accidentally paused your stream there.
I think so. Yeah, there we
No,
go.
you're back up. Okay, good. There we go.
Yeah. And Shana, what you just described, that mathematical process is called covariance.
Yeah.
So the basic fundamental starting off point for this was Voigt making the speed of light invariant, and to do that, he introduced covariance, which is the change in the other known variables in the equation that change to a ratio of some proportionality to facilitate the invariant of a known quantity, right? So like if they want to use the speed of light and make it constant, they have to change time and space.
Yeah, he was like, oh,
So-
guess what? The mass of everything just happened to shift a little in the direction that we needed it to. But don't
Right.
worry, because mass and energy are interchangeable and nothing matters. Like what? Whoa.
Right. And in the previous framework of physics, the Newtonian framework, time and space are absolute. So lengths and distances are the same for everyone. Everyone's is referencing to, with respect to the same absoluteness, where they were introducing a new concept where, lengths and time were relative to, your velocity, which is a complete disconnect from that. And so they also had to take mass and do the same thing, because mass would be, I forget the word for it, but it's like superposition. So like you can like add on top of it. So you can go like, I have 10 pounds here, there's 5 pounds here, there's now 15 pounds. Well, in relativity, you can't really do that because there's no thing to do the cumulative adding against. So they had to come up with a different way to do that. So like all this relating E equals mc squared and making everything relativistic and relativistic mass and making it equivalent to inertial mass and all that. All of this is related to getting people to believe in that covariant relationship, because if they can do it mathematically and represent it through the symmetry of the mathematical framework, they take that as like, this is definitely correct. It's absolute, but also not absolute,
The math proves that it's real.
Yeah, exactly. Like if you carry the 3 over and you get 13 out of it, you're good to go. But if you forget that 3, then like, you didn't do it right.
Relatively absolute, right? How's that for an oxymoron for relativist?
Relatively absolute is
Yeah.
such a good oxymoron for it too, because
It's
the Lorentz symmetry framework depends on midpoint symmetry between the two things in uniform motion relative to one another. So like
terms
it's
right up there
inherent-
with curvilinear.
That's what I was
Yep.
thinking. That was my inspiration. Yep.
So like as hard as they try to get away from it, it's like inherent to the framework. It's the backbone of it, and then they just don't acknowledge that at all, and act like the contractions are a real mechanism to erroneously explain an experiment that had a velocity component to it, but just not the one that they needed.
Any questions or comments from the crowd? We got a few people in this room here.
It sounds to me like Einstein stole a bunch of stuff.
It does sound that way, doesn't
does. My whole thing with it is that if he had actually no source when defending this, how come no one clocked him on it? And if so, why not?
Because they had to put this philosophical and mathematical framework forward as the only possible explanation to maintain a cosmological foothold, because their whole philosophy and everything was like they merged physics with their cosmology, which is that the earth is in motion and holds no specific relevance. And to do that, they started taking measurements, and none of their measurements comported with their cosmology or belief system. So they had to come up with this framework to explain how the earth could appear to be stationary but still in motion, and that could only be done through mathematics.
Wasn't there a paper
Okay.
or
Okay.
groupings of papers where they said it's like hundreds of scientists against Einstein, where it goes over how much of a plagiarist he was? Am I imagining that, or do you guys remember what I'm talking about?
That is the publication itself called "100 Scientists Against Einstein." Yeah,
Oh, nice.
that came out at the time. It is an actual publication. You bet.
Did we cover that, or did someone link that to me? Why do I remember that?
It's been posted a couple times to the main chat over the past months.
I love this.
If you guys do a reading night on that, I'll popcorn. I promise.
Oh yeah.
What do you think, Gally? Is exposing the truth counterproductive, even if it means the downfall of a hero and the death of a religion?
No, it's not counterproductive. I think it's good to expose the truth, even if it destroys someone whose equation is like Einstein equals married cousins twice. Like, I think it's fine. I think it's fine to expose the truth of someone like that.
Further, I think they should serve snacks while they're doing the exposition.
I
Yes.
like how this guy's like, listen, even if it's all meaningless and all the math that I just put forth is bullshit and has no actual meaning in reality, is it worth bringing down the fabulous legend of Einstein, guys? Really? To a room full of people he fully expected to be like, no, save Einstein, right? That's the tone in
Well,
the context. That's crazy.
he
I
pretty
wish
much
Morgan
invented
was here.
nothing.
Yeah,
Morgan would do
invented.
such a nice job at sharing this with us. I'm gonna ask him to join next reading night.
Nice. All right. Let's see. I think I covered everything I wanted to on the notes there. Stone, again, awesome reading, man. You nailed it. All those. It was fun to hear all the proper pronunciations for the French and
Is that
German
Yes.
stuff.
stream, guys?
Many thanks.
I like the way you punctuate words too, Stone, especially with like the laughter, the absurd parts. That definitely adds to it.
Righteous. Thanks, man.
All right. So let's see here. Friday night Twitter space. We'll be back on Friday. And then Sunday will be Globebusters. Stone and I will be doing a duo Prezi kind of on Holton Arp's Seeing Red. We'll be going over cosmological redshift. So, like, a big part of the philosophy put forward in mainstream and in physics is that there's this velocity going on in the sky that's super fast, and they can measure it when they look at light, and they can tell by the redshift in there that there's an expansion, everything's moving, but not us. Like, we can't when we try to do it terrestrially, we for our velocity relative to the sun, that can't tell. But for quasars and black holes and galaxies and stuff like that, we could tell that they're moving, based off of their redshift. So we're going to get into the specifics of all that and how they do their picking and choosings and what happened when their pickings and choosings were once challenged by somebody who had the academic backing to do that. And we'll see what they did.
And the data.
And the data. Dude, lots and lots of endless pictures of black and white things that we'll never really know what they are. But so yeah, join us for that. And for our 104th episode, we are doing a community showcase of things that you may have learned from Ether Cosmology, or things that you would like to share with us that you've learned, from somewhere else or whatever. So if make like a little presentation, send it in to my email. It's AlanSpaceAudits@gmail.com. And we'll go over that on our 104th episode, or you can come on, do a Prezi yourself, whatever you feel comfortable with, or we'll just read off whatever you wrote in.
And non-participation will be bullied and socially.
Yeah,
That would be hot.
Yes.
Yeah, I want to hear that. Things that made you say,
Yes. It'll be an awesome recap. And worst case scenario, we're going to go over a bunch of stuff that I learned from other people over the course of all this. So it'll be fun either way. All right, Shane, go ahead and wrap whenever you're ready, sir.